Looking at a frog population is the reason they call it polyfrog. And so looking at this, it asks us to get 1, 0. Would this be a cubic function with 1, 0? No. It's a linear function with 1, 0. So just because it has a 1, 0 does not qualify it. We have to get both pieces. It has to be both cubic, and I keep forgetting to put that up on my wall, but it's one that looks like this. That's a cubic function with 1, 0. It's one that kind of has an S shape to it. So with 2 zeros, think about the graphs we've been doing. It's how we've had the sun that will come back and touch and then go through. That's an example with 2 zeros. And then 3 zeros is really easy. It just goes through it all 3 places. And you could have drawn it the other direction or whichever way. It just, those are some examples of one that would fit both being a cubic function and having that number of zeros. The next part of it asks us, though, what is the domain and range of that function? First off, do all of these have the same domain and range? Are they going to cover the same x's and y's? Yes. What x's are they all going to cover? All of them? On this last test, some of y'all put these in the reverse order. It always is negative and then positive. So make sure you always put it as negative than positive. It's always smallest than largest. What about range? Well, I eventually cover all my y's. Yeah. So negative infinity to positive infinity. We don't have any stopping point, so I'm eventually going to cover them all. So now we're going to take our calculator and we're going to go to the spreadsheet part of the graph using x's in the first column, y's in the second column. So I forgot to erase my notes from last time. And we are going to enter in our data. Be careful in realizing that this does not go from 0 to 43. It will repeat some numbers, it will skip numbers, but the x doesn't count from 0 to 43. Once you have finished putting in the data with your x and the column A and column B, then go to Menu, 4, Statistics, 1, Stat Calculations, 8, Quartic Regression. And then you'll use the X list is going to be the A with the square brackets, and your Y list is going to be your B with those square brackets. So you should have come up with the equation that I've highlighted in green. Y equals 0.2319x to the fourth minus 20.236x cubed plus 540.05 x squared minus 4378.6 x plus 10,604. And that had an R squared value of 95% roughly. So I want y'all to go ahead and type this in your calculator. And when you type it in your calculator, I want you to go ahead and adjust your graph so that it can match what's on that next page. And if you look on the next page, this equation is written on your next page. So if you have troubles reading what I have up here on the board, just go ahead and read it from there as well. So go ahead and type that into Y1 and graph it. And then adjust your window. Remember, to get to your window, you do menu, window settings. And I think it's 1 on that. So window menu for 1 will bring up to menu where you can adjust your screen to set up like this. Your graph should have looked something like this. Let me know if you need any help with it. And so we're going to use this graph and look at it and analyze it. So we're going to be using a lot of the menu functions. We're going to use menu 6 to do different things. So know where that button is. Because it's going to help us find our low points or high points where we cross the x-axis and things like that. Okay. So consider the graph and the equation to answer each of the questions. What is the domain and range of the study? So is the study referring to the graph or the data that was collected, do you think? The data. So the study is referring to that data. So when we looked at our data, what was our smallest x, which remember for domain, it's our x's, and the x's are representing the months. So what was the smallest month that we had in our data? What was the smallest one of these? 0. What was our largest month? Range. That was the number of eggs observed. What was the smallest number of eggs observed?
108.4.
What was our largest number?
15,966.
So when we're dealing with this was dealing with the eggs observed, really more the average number of eggs observed in that month. And we're looking at the study, we're looking at the data. But if instead I ask you what is the domain and range of the function, what's that asking instead? This is asking you of the graph. So if we're to look at the graph, and we weren't to consider a story behind it, for your domain, your x's, what is the smallest x you could come up with? Where would this graph go? Is there any stopping point? So negative infinity. What's this largest x? Keeps going. Range, we're going to look at the same thing, but this time we're going to look at y's. What is the lowest point I can go to? Right there, right? So we need to find out what the y value is here. So if you'll go to your graph, and you're going to find the minimum around this point here. And so if you'll go to menu, and then you'll go to and then go down to 6, and then we're looking at the low point, so we're going to go to minimum, and then just bring your cursor around that point. Some of you may have your calculators inside to make notation. If that's the case, I can help you get it out of it. But you should have come up with a negative 207.1. 2 there, if I go further out. And so what is my highest point? And that's a square bracket there. Keeps going. So infinity. When were the most of the frog eggs observed? So in other words, when did this happen? So at 24 months, we had 15,966.9 eggs observed, and that was the max number of eggs we observed. When were the fewest number of eggs observed? In the 7th month. And we only observed 108.4 eggs. And that would be your minimum. So the next thing, it wants us to predict. We are wanting to see what is going to happen at 50 months. We did not do our study out to 50 months. So what are we going to use to help us predict? Your graph. And so y'all are going to use your trace feature and go until your x says 50. How many eggs were observed in the 50th month that this pattern continued? 61,674. And so, do we know for certain this is how many are going to happen in the 50th month? No. Based upon our data right now, we have a quartic. But what if I keep going and then I start seeing it trend back down? Then it may be a different type of graph. So based upon our current graph, this is the data we have. How many frogs appeared between the months 35 and 40? Did we record anything between that 35 and 40? No. According to our function, we had a negative number of eggs. But is that reality? No. We either have no eggs observed didn't take data or something. There is a problem with our data in this loop right here. So when in the study did we see approximately 4,800 eggs observed? Based upon my graph, it should be about 4 times, right? How can I figure it out based upon the graph? Easiest way is to graph the intersection of y equals 4,800. Let me get back to where I'm in a good setting. And then find each of these intersections. So why don't y'all find those intersections? So you should have found that roughly at month 2, 11, 31, and 43, you had that happen. Months. 2, 11, 31, and 43. So now we're going to use our graphing technology and we're going to actually find where are my intercepts. And while we're there, let's go ahead and find out our maxes and mins. So I want you to find all your x-intercepts and all these maxes and mins. So this is the data you should have come up with on your graph. From here, the blue is what you'd put on number 1, and we'll go over 2 on tomorrow.